All right, so we are doing some practice problems now for week 3 lesson. So first one here, the NAND gate is often called the universal gate. The reason for this is because you can create any other gate using only NAND gates. So if you had only one set of chips, if you had the chip that contained the NAND gate, you could create whatever circuit you wanted to just by using that chip. Okay, it would not be ideal, it's not efficient, but you could do it. All right, so that's why we call it the universal gate. You can actually create all the other types of gates by just using the NAND. Kind of like you could say, if I have a map of a bunch of city blocks, and you were trying to map out how to get somewhere, and you could say, I need to get to here, from here. So I need to start from here, get over to here. Can I do that by only making left-hand turns? Like, yes, you can. It's not the easiest way to do it, but you could get there by only turning. If all you could do was turn left, you could do it. Okay, it's not the best way to do it, but it is possible. That's kind of what we're saying here. So here's a challenge for you. Try to draw the other 5 types of gates we have discussed here by using only NAND gates. So for example, how would you create a NOT gate by using only a NAND gate? You could do that by doing this, basically taking the 2 inputs and tying them together. And then the solution here would be you put in A and you come out with A prime or A bar. Okay? So taking a single gate, how could you modify this? How could you wire this up to get that as a result? Well, if you connect those both together, so now you're going to have A and A, A and A, NOT is equal to A NOT. That would basically be the same thing. So you've just basically created a way to create a NOT gate by using only a NAND gate. So try to give that some thought. Think about how you could create all these other 6 gates, so the rest of the remaining 5 gates, an AND, an OR, a NOR, an exclusive OR. Some of them get kind of big after a while, but some of them are pretty simple. See what you can do for that. Okay. These are the solutions to that, but give that a little bit of time on your own. Think about what you want to do there. See if you can draw those out. These are the solutions. Okay. Practice problem number 2. Using these ICs, create the circuit on the left. So how can you create this circuit? If the challenge was in the lab, create this type of circuit using these chips that we have here, how would we actually do that? So how do we create a desired logic circuit? By wiring together these chips. So let's look at this. So that's our circuit. So first of all, we're going to take our 5-volt power. We need to connect that to each of our 5-volt powers. We're going to take our, I should have done that in a different color. Do this in black. Should have done that one in red. Maybe I'll change that around. Let's take our 0 volts. Connect that to here. This will take advantage of the colors that I have. So that would power all the chips. That's our first step, power all the chips. So now we've got A, B, and C. So we have A goes into, so I'm going to draw this out here. So let's look at chip number 1. Let's call this 1 and 2. Now looking at this diagram here, chip number 1, inputs are 1, 2, output is 3. So I'm just going to label this here. 1 and 2, output is 3. Chip number 2, inputs are 4 and 5, output is 6. Output is 6. On the OR, input is 1 and 2, output is 3. One and 2, output is 3. On the inverter, input is 1, output is 2. Alright, so let's go ahead and fill in these wires here. So signal B is going to go into the inverter chip, pin number 1. So let's just say B into pin 1, and then pin 2 on the inverter is going to connect to pin 2 on the AND chip. Just going to draw that across here. I'm going to put a line here where it jumps into pin 2. It's also going to connect to pin 4 on the AND chip. Alright, the other thing I'm going to do here, this is a really good lesson I learned from people. If you have a diagram like this and you're trying to wire it, I'm just going to scratch things off as I wire them. Or I've seen people highlight them as they go. Okay, so that's that. A goes to pin 1 over here on this chip. C is going to go to pin 5 on that same chip. And then I'm using a different color for everything here, just to make it easier for you to see what's going on. And then we go from pin 6 on the AND chip to pin 2 on the OR chip. We also go from 3 to 1 And then our output finally is pin 3, and that's going to go to Y. Okay, so that is how we would wire this circuit. And that is a pretty common task of what we're going to be doing in this course, is looking at a circuit like this and trying to figure out how do we actually wire it. And this is a pretty good method of how to do that too. So between these diagrams here, translate those pin numbers to your diagram, label them, plan it all out, and then actually put your chips on the board, wire them as you go, scratch them off, check them off to make sure you didn't miss anything as you go, and create your circuit, and then test it and troubleshoot it. Okay, so that is putting together a circuit using our chips. You can actually try this one in Tinkercad if you chose to as well. I think we have the, you can create the truth table for this too and verify the truth table. Alright, and then this one here, draw the logic gate circuit and create the truth table for this. So this is kind of going in the reverse order. So here we have one chip. So I notice that we have input A and input B. We have one output, which is Y. So right now we've got, I'm going to cross these off here. So Y comes off of 8. (11) and 10 are connected together. (9) and 6 are connected together. (12) goes up around, comes down to input A. (13) comes around to input B. (14) just goes to power. (1 and 2 both go to B. (3 and 4 connect together. 5 goes to A. So that's it. So let's draw this out now. So we're using all 4 gates. So we have B, both legs of B going into, so let's draw this one here first. So these are both connected together. That's coming out. And this is feeding into one leg of another gate. And the other leg of that one comes from A. We'll draw this once. We might want to redraw it later to make it look better. And that's this so far. And the output of this goes around to the input of another gate. The output of this gate is actually our output, our final output. And this also comes from the result of another gate down here, which receives A and B. So let's just go back and double check this to make sure that we are okay here. So if we call this 1, 2, 3, 4, so 1, 2, 3, 4. So this is 1, 2, and 3. This is 4, 5, and 6. This is 9, 10, and 8. And this is 11. A goes into 12 and 13. Okay, so that checks out, and then we should kind of be able to verify that against this diagram too, but I believe this is correct. So that is this guy here. So now if we want to make a truth table for this, I guess that would be the next challenge here. The truth table. Alright, we'll see if we can do the truth table. That's going to be pretty challenging. So we have, coming into this, we have just B. So coming out of it, we have B naught. Coming into this, we have, that's A and B. So this is A and B naught. So this is B naught. This is A. This is A and B naught. So then our final result here bar over the whole thing. We're not going to do the truth table. Don't worry about doing the truth table. This got very complicated. Yeah, we won't worry about that. But basically, that would be the final equation there. Next, in a couple weeks, we're going to learn how to break this down into something simpler to solve it. But for now, we're just going to leave it there. But the purpose of this one was create this diagram from this circuit. Okay, so this is the backwards. So we did creating a circuit from a diagram, and then creating a diagram from a circuit. Okay, so that's two different methods there. Alright, so those are different problems to practice with. And that is the end of the practice problems for this week. We will good luck with that, and we will see you next Thursday.